Hello everybody and welcome to our webcast for our project in the course Cloud Computing. We implemented a vulnerability notification system, and we are going to explore in this webcast what we mean by a vulnerability notification system, which component has it, which users are the main target group for the project, and the implementation details, and of course a live demo of the application itself. So let's get started. Let's start with a short project overview. The purpose of our vulnerability notification system is to notify the users about vulnerable applications which they might run on their local machines. The user group is nearly everybody that is concerned about security. The application category is software as a service, or we also provide a platform as a service. We will go into details on this special point later on. And our implementation uses infrastructure as a service, platform as a service, and software as a service aspects. We will also cover the details later on. So let's start with the basic introduction. We implemented a client monitoring component which analyzes vulnerable applications, and these vulnerable applications are identified by Microsoft Azure Cloud Service. We used a lot of different technologies for this project. The implementation was done in C# with the support of Visual Studio 2013. We used the Microsoft Cloud environment to provide the cloud service parts of the system. And we used a variety of different frameworks like VPF, ASP.NET, the Entity Framework, and many other .NET related frameworks. For package capturing on the client side, we used WinPCAP in combination with SharpPCAP. And for the application identification process, we used the 7-zip and Sandboxy software. ASP.NET was extended with SignalR for real-time client notifications, and Log4net was used for logging purposes in all components. So let's get right to the architecture of our system. We got basically two parts. One is the client side and one is the cloud side. On the client side we have a tray icon, which is the user interface, where the user sees the active applications and their vulnerability status. The tray icon gets the data from a network monitor, which monitors all client network traffic. Then it determines the applications which are responsible for the network traffic. It inspects the applications, creates fingerprints of the loaded modules from these applications, and sends this information to the cloud service. The cloud service has several components of its own. One is the vulnerability management, which provides the administration interface to add new applications and vulnerabilities by an administrative user, and it provides the real-time notifications for the network monitor. This is done in SignalR. The other cloud service is the vulnerability identification, which gains the module information from the network monitor. Then it identifies the applications and sends the result with including the vulnerability status back to the network monitor. As database to store several informations like users and the applications and the vulnerabilities, we use a SQL database, and the application identification process also uses this SQL database. The application identification process uses also the blob storage, where the binaries which are submitted in the vulnerability management are stored temporarily restored and then analyzed by the application identification. Then the application identification analyzes these applications and stores the results in the SQL database, where the vulnerability management and the vulnerability identification can access this information. So this was right at the start. We are done with the architecture, and let's get to a live demo. We are now inside my development virtual machine, and I'm going to launch the network monitor and the tray icon application. The network monitor requires administrative privileges, as this is required for the inspection process. So we launch the network monitor. Okay, it's up and running, and we launch the tray icon status. Okay, right now we have no active applications which access the network. I'm going to launch a Firefox application. As we see in the background, the network monitor service already accessed the network because it queried the vulnerability management for the real-time notifications. So if I'm going to access the web in the browser, the network monitor analyzes it. We see it right here. Firefox accessed the network, and the application was identified as Firefox 26.0. And this is also shown in the tray icon application, where we also see a nice overview over the vulnerability status. Right now the Firefox has no active vulnerabilities, and its exact version is shown. We can verify the version by clicking the About dialog in the Firefox. Okay, so right now there are no vulnerabilities. Let's switch to the web application. This is right here. I've previously created a user. We are not going to do this right now. I'm logging into the web application. This is the start site, and let's check out the releases. We already added two applications. One is the Firefox 26.0 and one is the OwnCloud client. So I'm going to create a new vulnerability here. A vulnerability has a title. I name it test vulnerability. A description, for example, we can put here a CVE number or something like this. And I'm going to select the vulnerability is for the Firefox 26.0. When I click the create button, it creates a new vulnerability, and you see right here over in the virtual machine, the vulnerability status has already changed. Now it's a vulnerable application. If I delete this vulnerability, the status is updated immediately inside the virtual machine. Okay, this was the live demo. I'm going to shut down now the applications, and we are going to take a look at the implementation. The implementation is basically done in three big project parts. Right here we see the solution for part of the cloud services. We created a Microsoft Azure based service, and it has basically two roles. One is the application verifier, which is called also vulnerability identification. This is where the network service sends the module information to the cloud service, and it gets identified there. And one is the vulnerability management. This is the website we just saw. And these are the two applications, and the data model, which is implemented with the entity framework of C#, is contained in its own assembly and is shared by the other application components. We also created the network monitor, which contains the client-side components. One is the network monitor. This was the console application which we saw just running, and the tray icon status. This was the user interface we were seeing moments before. And the third part we have not seen yet is the hashlib creator. It is used to to extract the information out of the applications we use. We are going to take a look at this a little bit later on in detail. So, yeah, we've also implemented this in the Microsoft Azure Cloud. The site is reloading right now. I have to relog again. Okay. Right here we see the overview over the Azure instance of our Azure account. We got several different types here. We got 3 storage accounts. One, this is created manually, and we use this to store the files submitted by the vulnerability management. This is the default storage account which is created when you deploy a new cloud service. This is the service when you create. This is the storage service that is created when you deploy a virtual machine. Then we've got 2 cloud services here. Actually, we only use one. This is the WS2013 service. Then we've got a virtual machine, which we are going to take a look later on, and we got the SQL database, which stores the data. So, okay, let's take a look at the cloud service. Right here we see this one is running in the staging environment. This is also where we deployed our solutions. And if we take a look at the dashboard, we see there was some CPU and other activities right before. This was when our test was done. We've configured nothing specially here. It's just for documentation purposes that we showed this part of the application. So, another topic we haven't covered yet. If I want to create a new release, I can enter release name, and I can select a binary. For example, I select here the Firefox setup binary. I'm not going to upload this now, but I can show you what happens in the background. So if I select this binary and click create, the web application stores the binary in a storage container, and we use this specific storage container. You see there are already some containers deployed already. We use the my container, and there's currently no content because the content is immediately removed. Why is the content immediately removed? Because we got a virtual machine running in the cloud. This is the app ID WS2013. I'm going to connect to it right now, and we can see what happens there. I open the remote desktop desktop connection to the machine. Takes a little while, but it usually is very fast. Okay, and right here we have the application identification deployed. This is the solution we saw right before. This is the hashlib creator. I'm going to launch this application now. And this application listens for changes in the storage container, and if, for example, a new binary is added, it downloads the binary, removes the binary from the container, and processes it. We can simulate a processing step right now. For example, if as before, I selected the Firefox 26. This is stored in a temporary directory. I've downloaded it for demonstration purposes. I select this application. I can configure several export options. When we use the Azure export options, it is stored to the SQL database in the Azure service. I'm not going to select this now because we already added Firefox 26.0 and it would cause duplicate results. And if I click the add button, a new task is launched, and the setup for the Firefox is automatically executed. You notice right in the when I move the mouse over the window, it is yellow. This is because we used a sandboxing software called Sandboxy, which we can see, which I will show you later on. And okay, we are done with the wizards. The installation is now complete. This is the rest of the Firefox process, and we see in the overview, Firefox launches now. Okay, we don't want that. We close it down, and we see in the overview the task is completed, and the contents are hashed. We see here, for example, here's the Firefox executable, and here are a bunch of hash sums which are calculated, and we use the SHA1 checksum. This installation was launched in the Sandboxy controller. It is a sandbox environment which allows applications to run in a sandbox and not modify the hard disk. So it's an basically isolated environment which you can test stuff out, and we use it for performing an automated installation and hash the results. The application also supports not only executables, it supports archives, basically every archive which 7-zip can extract. It furthermore supports MSI installer, and as I already demonstrated, it supports the automated installation. So when this is all done, the results are stored in the SQL database, and I can show you right now that they are actually in there. We are going to connect to the management portal of the SQL server. It actually takes a while to load. Yeah, while the management of the SQL server is loading, I can express my experiences which we gained during the project development. First of all, Microsoft Azure is quite comfortable to develop. It integrates very well into Visual Studio. I can show you how it's done right after we've inspected the SQL server, and it works very well. We had several problems with the local debugging environment where services were not starting correctly or the database connection would fail or stuff like that. But once you deploy it into the cloud and enable debugging there, you basically don't need the emulators provided by Visual Studio to do the development. The deployment takes quite a while. I've got a quite slow internet connection, and it takes about 10 minutes to deploy a package of the application to the cloud. But if you don't do it too often, it's usually not a problem. Okay, let's take a quick look at the database. We can select database here, and we switch to the design view. We see here the tables which are created by the entity framework automatically, and we see already in the modules info table are 192 entries, and of course we can take a look at the table, and we see a lot of different stuff which is related to the Firefox web browser, and this is all stored in the database. Okay, this was a short view on the database side. If we switch back to the virtual machine, I can show you how to deploy the solution to the cloud. It's really very easy. Basically, it's just click the publish button and run the wizard behind it. I can show it. It asks several questions. First of all, you have to sign in with your Microsoft account or your Microsoft Azure account. Then you can select the cloud service which to deploy the solution into, which environment. This is the build or staging environment. If you want to enable the remote desktop, if you use HTTPS, which we do not use in this project, you can provide certificates, and you can configure several other service-related properties. Where to go with this solution? Of course, it has some shortcomings, as we have seen before. The network monitor is currently running as a console application. In a real world scenario, you would run this as a Windows service. Also, the user interface is not fully developed. It's just a mock to provide the user with the feedback. For example, it would be a nice feature if the user could actually, if a vulnerability occurs, end the process. Regarding the cloud service, we didn't use HTTPS. We had several problems implementing it. You have to consider a lot of stuff regarding certificates and stuff like that. And the data model we used is not very sophisticated. It's rather held very simply to just achieve the functionality which we were aiming for in this course. Okay. To sum it up, we had a lot of fun implementing this project during the course. Short shout out to the course lecturers Matthias Steinbauer and Ismail Kali for their support and the nice lectures they gave us. Also, the course lectures itself were very interesting, and this was it from the vulnerability mitigation system. We hope to provide a download in the future if you want to try it out yourself. Thanks for your attention.